So I arrived really late on Friday night, and like I say, it was my first ever MathsJam, and I walked up and I saw this warm glow coming from the bar, but I was on the outside just kind of looking in at the windows, and as I looked in, I saw Adam just kind of wowing everyone with all of his big box of tricks, basically, and it was a really wonderful first moment for me in MathsJam. Unfortunately, I was kind of locked outside of the bar, just like rapping on the windows trying to get in, but I could tell that everyone was having a fantastic time in the bar with him, so it makes me very, very happy to welcome to the stage Adam.
Hello. Yes, can we have my slides up, please? Continuing in my tradition of giving talks about applying maths to real-world problems, I'm here on behalf of the MathsJam Time Travel division today. This is briefing 17 in a series of talks. You'll have attended the first 16 in the next few centuries as part of your time travel practicals. So submit your logbooks for those, please, by next Wednesday. Or last Wednesday. Now, we really like the question, when will I use this in the MathsJam Time Travel division, because the answer in this particular occasion is between about 1590 and 1614. Couple of tips: don't destroy the universe, don't change history. I have to fill in lots of really boring forms every time you do that. So what I'm talking about is prostaphoresis, which is a very long word starting with P. If you have to multiply lots of numbers with locals between 1590 and 1614, witnessing you doing it, you can't use logarithms because they haven't been invented yet. But in this 25-year window, people used cosine tables to multiply numbers, because somebody had noticed that the product of two cosines is equal to the sum of two other cosines, and that produces a product to a sum which is easier to calculate by hand, and better ideas hadn't come along yet. So let's do a worked example. Let's multiply 2,000 by 400. Now, I've chosen these to be something where we can do the answer another way. We divide those by 10,000 and 1,000 so that they scale down to be numbers between -1 and 1, so that they're the cosines of something. We get 0.2 and 0.4. We look up arccos of 0.2 and 0.4. Radians haven't been invented yet, so don't go around using those with locals observing you. So that's 78 degrees, 28 minutes, and 66 degrees, 25 minutes. The difference in some of those are 12 degrees, 3 minutes, and 144 degrees, 53 minutes. Look up the cosines of those, add them, divide by 2, and you get 0.08. But remember, we scaled by 10 million at the start, so we have to multiply by that again, and we get 800,000. Isn't that convenient? You might ask yourself, but how do I divide? Well, it's simple. You need a table of secants to do that. So to divide 300 by 3, I divide 300 by 1,000 to scale it down to 0.3 so that it's the cosine of something, but I leave 3 alone and I look up what arcsec of 3 is, and whatever that is, its cosine is a third. And then I do the same calculation as before. So I get two angles whose difference and sum are 2 degrees and 45 seconds and 143 degrees, 4 minutes and 15 seconds. Add those up, divide by 2, multiply by 1,000 to scale it back up again. I get 100, which is the right answer. Isn't that lovely? In case you're wondering which lunatics went around doing this, well, it included Tycho Brahe, who's fairly well known, and some guy called John Napier. So in case you're wondering why this stopped in about 1614, I think we now have the answer to that. And that's it. So if you want to try actually doing this, I have some cosine tables with me that you can try doing it with yourselves. I don't have any arccos tables, so you're just going to have to look up the values inside the cos table, but that's fine. There are logarithms in here, so don't travel back to the 16th century. Thank you very much.
Thank you so much, Adam. Adam Atkinson, by the way, our second Adam of the session there. MathsJam has a lot of multiple name people. I know that there are